a base is made up of two ions. One, a metal, which is the positive ion, and second, the negative ion or the hydroxyl ion. And what is an acid? An acid is hydrogen ion, which is the positive ion, and the non-metallic ion, which is, say, X. Now when these two combine, what happens? Hydrogen and hydroxyl ion combine with each other to form water. And metal and non-metal form salt. So basically, salt is a compound which has a metal and a non-metal. So whether it is a carbonate or sulfate or nitrate, all these are salts which are derived from various acids. Now for example, let us find out how is sodium sulfate formed. This will be formed from sodium hydroxide and sulfuric acid. Potassium nitrate from potassium hydroxide and nitric acid. Calcium chloride, calcium hydroxide and hydrochloric acid. So depending upon which base and which salt, we have different type of salts. And obviously their nature will also change accordingly. Now the salts which have been derived from strong acids, they will be acidic salts, and which are from strong bases, they will be from basic salts. Just like you have your parents, sometimes you say I am Papa's son or Papa's daughter, and sometimes you say you are mother's daughter. So to whom, or even say, let us take the case of resemblance. Sometimes a child has more resemblance towards father, both in the physical features as well as behavior. Sometimes it is more towards mother. So although the child is a progeny of both, but the inclination can be towards one parent. So in the case of salts also, now let us take the case of, say, acetic acid, which is a weak acid. Now when this combines with a strong base, then what we get is sodium acetate. Now can you guess what will be its inclination towards? Acetic acid is weak, but sodium hydroxide is strong. So this will be a basic salt. And if the acid is strong, and the base is weak comparatively, like aluminum hydroxide, what we will get is aluminum nitrate. Now here, the nitrate or the nitric acid will have more dominating influence. So the salt will be acidic. But what if both mother and father are equally dominating? Then the effect is neutralized. So these salts are neutral. Another example of a basic salt is the sodium carbonate and sodium bicarbonate. So now we are going to study about these carbonates, which play a very, very important role in our daily life. Because can you have your cakes without soda bicarb or the baking powder? You can't have. That fluffiness, that sponginess is the effect of baking powder. Even your idlis, dhokla, all wherever carbon dioxide is required to be trapped in the batter, we use baking powder, right? And then we also need to clean our clothes. The detergents, the soaps, what do they have? They have washing soda. So let's go for baking soda. The baking soda is soda bicarb or the sodium bicarbonate. Bi here means hydrogen. Sodium hydrogen carbonate. This is formed by the action of carbonic acid and sodium hydroxide. Carbonic acid is a weak acid. Now this baking soda has many uses. Some of the uses are, it is used in making baking powder, and even when we want to expedite our cooking, we want our gram or the things that take longer to get cooked, we want to finish them fast, then also washing soda is used. Now because it is a basic salt, so it is also used as anti-acid. So whenever we need, whether it is a sting by the honeybee or it is the nettle plant or it is acidity, you can use soda bicarb as an instant relief. So soda bicarb or the sodium hydrogen carbonate has a very important role in our life. Commercially, soda bicarb is prepared from salt. So you can take NaCl plus CO2 plus H2O and ammonia. So what we will get is NaHCO3 plus NH4Cl. But what happens when we add soda bicarb to our food? And especially if it has been put in excess, you get that bad taste, a little bitter taste. Why that happens? Because whenever NaHCO3 is heated, we get sodium carbonate. And carbon dioxide is released. The advantage is that this carbon dioxide gets trapped in the batter, and that is how your cakes become spongy and dhoklas and idlis and whatnot. But if it is in excess, then excess of sodium carbonate gets formed and that spoils the taste. Now let's get back to our cleaning of clothes especially. How do we do it? With soaps and detergents. And what do they contain? They contain washing soda. Washing soda is also a carbonate, but it is only a carbonate, not a hydrogen carbonate. Plus 10 molecules of water. What does that mean? Is it wet? This is the water of crystallization, which means so many number of water molecules are associated with one molecule of a particular salt. We'll study that later. So in the case of washing soda, it has many uses. It is used in soaps and detergents. It is also used in glass industry. It's a cleaning agent. You can show these 10 molecules of water if you take sodium carbonate in a test tube and heat it. So what we will find is water drops at the test tube. This shows that water molecules are associated with sodium carbonate. Not only with sodium carbonate, they are also associated with other salts. Example, copper sulfate. Copper sulfate has 5 molecules of water. What is the color of copper sulfate? It is called in common language Neela Thotha. Why Neela? Because it is blue in color. Blue vitriol. Now this copper sulfate is also called, so if we heat it, not only we get water drops, the blue color changes to white. If you again sprinkle some water on that white copper sulfate, it turns blue. So the blue color is due to the presence of water molecules. But be careful, copper sulfate is poisonous. Because it is poisonous, it has many uses also. It is used as a fungicide or the pesticide. But one has to be careful because it is poisonous even for the human beings. In the case of calcium sulfate, which is called gypsum, gypsum is CaSO4. Now when this calcium sulfate is heated at 373 K, then what do we get? We get calcium sulfate and half molecule of water. While here we have 2 molecules of water. So this is called calcium sulfate hemihydrate. Now how have we used this? We have used it for making POP, that is plaster of Paris. When water is added to plaster of Paris, it becomes a thick paste, and as it dries, it becomes hard. And that is why the surgeons use it when you have fractured your leg or arm. When I say you, I don't really mean you. Anybody, whether it is a child or an adult, due to an accident, if there is a bone fracture, then we don't want bone to move. Not only it is very painful, it will not heal. So what is done? The limb is put in a cast, and that cast is made up of plaster of Paris. It's not only for writing get well soon, it is also for setting your bone. So what happens? That calcium sulfate on heating forms hemihydrate, and on adding water it again becomes calcium sulfate.